Hi, I'm Will Dangler, and this is the third episode of The Art of Math Proof. In the last episode, we proved that if we took any two even integers and added them together, we were always going to end up with another even integer. Today, we're going to prove something very similar. We'll show that the sum of two odd integers is also going to be an even integer. Now, we want to prove a result about the odd integers. In particular, that if we add two of them together, we'll get an even integer. We're gonna need to know what exactly we mean by an odd integer, just like we needed to formally define exactly what we meant by an even integer in order to prove that the sum of two even integers was also going to be an even integer. So, what is an odd integer? Well, the odd integers are all the integers that aren't even. Okay, well then, what are all the even integers? Well, we said that the even integers were all the multiples of 2. So the odd integers are the integers that aren't the multiples of 2. Okay, well that's a little weird to say. Let's zoom in on the even integers a little closer. So the multiples of 2, what exactly are they? Well, there's 0 and 2 and 4, 6, 8, etc. You know, the even integers. And so if the odd integers are all the integers that aren't even, we know that the odd integers are going to be 1, 3, 5, 7, 9, and so forth and so on. Okay, so if these are the even integers, the multiples of 2, and we have the odd integers, all the ones that aren't even, we can notice something. Well, the even integers, they're every other integer, starting with 0. And the odd integers are also every other integer. However, instead of starting with 0, we're going to start with 1. Okay, so now we have a better idea of what exactly the odd integers are. Just like the even integers, they're every other integer, except the even integers start with 0 and then move on, and the odd integers start with 1. Okay, so we have a better idea of what is an odd integer. So if we want to codify exactly what we mean by an odd integer in a similar way to how we defined an even integer, how can we do that? We can't just say, well, the odd integers are every other integer. Well, let's take a closer look. We see that we've got the even integers here and the odd integers, and we can notice that, well, I can take 0 and turn it into 1 by adding 1 to it. And I can take 2 and turn it into 3 by adding 1 to that. And 4 can go to 5 by, again, adding 1, and 6 to 7, and 8 to 9, and so forth and so on. So if we have the even integers, we can get all the odd integers by shifting them over one value, or in other words, by adding 1 to the even integers. That will give us the odd integers. But we already know what the even integers are. They're the integers of the form 2 times u, where u is another integer. So if the odd integers are all the even integers shifted over 1, or all the even integers plus 1, we can take our equation for the even integers and simply add 1 to it to get the odd integers. So let's write that down. An integer is odd call our integer t. If there exists another integer, let's call it u. Such that t is equal to 2 times u plus 1. Okay, so now we have a definition for what it means to be odd that looks incredibly similar to our definition of what it means to be even. We said an integer t is odd if there exists an integer u such that t is equal to 2u plus 1. And we got this equation by saying, well, the odd integers are all the integers that aren't even. And we noted that, well, we can turn all the even integers into the odd integers by shifting them over 1. And then we also noted that we know we can represent all the even integers as 2 times u. So to get our odd integers, we first take our even integer, and then we simply add 1 to it. Therefore, this is the definition of what it means to be odd. Fantastic. Now that we have a definition of what exactly it means to be odd, we can go about proving our statement that the sum of these two odd integers is going to be an even integer. So let's do that. Well, if I want to prove that the sum of two odd integers is going to be even, I'm first going to need two odd integers. So let's assume I have two odd integers. Let's call them x and y. What are x and y? I don't know. They're odd integers. And since we'll be talking about the sum of x and y, we might as well give it a name. Let's call it z. So we'll let z equal the sum of x and y, or we'll let z equal x plus y. Okay, great. So just like in our proof for the sum of two even integers is an even integer, relied on the fact that we use the definition of what exactly it means to be even, our proof of the sum of two odd integers being an even integer is also going to rely on our definition. So what exactly is an odd integer? Well, we said an integer t is odd if there exists another integer u such that t is equal to twice the value of u plus 1. In other words, t is equal to an even integer shifted over 1. Okay, well, x and y are odd integers. Well, that means that they can be written in this form. So let's do that. Let's write x is equal to 2a plus 1, where a is an integer. We know that y is going to be equal to 2b plus 1, where b is an integer. And we know this because both a and b, both x and y, are odd integers, so we know the integers a and b must exist by our definition of odd. Okay, and just as before in our proof of evenness, now that we have x and y in another form, we can substitute them in for equation for z. So since z is equal to x plus y, I can substitute in 2a plus 1 for x. I can substitute in 2b plus 1 for y. So let's do that. So z is going to be equal to 2a plus 1 plus y. And substituting in the y, we're going to get 2a plus 1 plus 2b plus 1. Okay, so now what? Well, we can rearrange these terms. I can add these ones together. So we get z is equal to 2a plus 2b plus 1, or in other words, plus 2. Then we can factor out our 2. So we get that z is equal to 2 times a plus b plus 1. Okay, so now what? Well, in our last proof, we got that z was equal to 2 times a plus b, and we noted that a plus b was an integer. This time we have 2 times a plus b plus 1. Well, a and b are integers, so a plus b is going to be an integer. And then one more than that will also be an integer, because we know that if we add together any two integers, we're going to get another integer. So we can give a plus b plus 1 a name. Let's call it c. Well then, z, which is equal to 2 times a plus b plus 1, is equal to 2 times c, where c is an integer. But wait a minute, we said an integer is even if there exists another integer such that the first integer is equal to twice the value of the second. And right here we have an integer z, which is equal to 2 times c, where c is another integer. So in other words, z is twice the value of c. But that means that z is even. Okay, well, if z is even, well, what was z? Z was x plus y. And what were x plus y? Well, x and y were any odd integers. So we took two odd integers, we added them together, and using that, we showed that their sum z is going to be an even integer. Therefore, we have proven that the sum of two odd integers is always going to be an even integer. Now, in the next episode, we'll prove that the sum of an even and an odd integer is going to be odd. Until next time, this has been Will Dangler.